Okay, today we're doing two board work problems. Autonomous systems like we've been doing for the last couple days. First one is x prime equals 60x minus 4x squared minus 3xy. Next one, and then y prime is 42x minus 2y squared minus 3xy. This one is almost the same, except for these two pieces are the same. I guess I switched these with those coefficients, right? So it does make a significant change for the phase plot, but I want you to do them both individually. I have the solutions on the next two pages, so you should pause, and then I'll go through each solution set. All right, here we go. That is the phase plot for the first one right there. I have 4 critical points. I'll go through how I got all this. So first thing I did was factor this thing. 0, 0 is clearly a critical point. And then 0 here makes a 0 there, which makes y21. 0 here makes a 0 there, which makes x15. Yep. And then setting the innards equal to 0 and solving that system, however you want to do it, REF, whatever, you get 612. Then I do the Jacobian, and I get this thing. Those are my partials. Come down here. The first three are all triangular matrices. So when I plug those guys in, I get easy eigenvalues for this one, 60 and 42. 1, 0 goes with that one. 0, 1 goes with this one. This is my like super shorthand way to do this, where I just like do a little squiggly because I know it's a number, but I know that it doesn't matter what it is because I'm just going to take 1, 0. I did the same thing here. So I've done a lot of that throughout this example. And if we were in school, we would work our way up to that. All right, so let's see, what else do I have here? This one well, sorry, I'll go through it. This one so I get a source. And remember, I only care about the first quadrant phase plot, so I'm just going to draw that and that. Come down here at 0, 21. I get triangular again, eigenvalues of 3 and 42, so that's going to be a sink. I just got to figure out the direction of the sink pieces. When I plug in that -3, did I say 3 earlier? It's -3. When I plug in that -3, I get this thing. So I do a little flip and negate, where I think that's a +13, and this is a -21. Um, so I go over and down, right? And then, no, yes, yes. This one of these should be positive and one of these should be negative. Anyway, that gives me this sink that comes up like this. And then this guy's easier. It's just a 0, 1, so it comes vertically and it sinks in. 15, 0, pretty similar to this one, except for I get a 1, 0 with this eigenvalue of 60. And then here I get a 3, -3, and I get 57, 45, so I can flip and negate and simplify. You could always like math frac to simplify that if you wanted. So once again, this goes like this, and la 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 la. This arrow here should be pointing in, not out, because it's a sink. They both have negative eigenvalues, so this should be going in down to there. With this one, talk about shorthanded things. 612. Do my eigenvalues. I think I probably graphed this or used the quadratic formula. I only really did this upper one, and then I got one -4.1, and then I did this one, and I got the same thing, but one was positive, um, which gives me this guy. Bottom line is that one of them, the one that kind of the eigenvector that is like positive in both pieces, has a negative syncness to it. And then the other one grows, right? So I get this in and then out and out. Come down here, put it all together, this out is going to connect with that one. This out is going to connect with that one. This one's going to slide in. This one's going to slide in. And then I'll get everything. So basically, whatever is going on here, I always either sink into this spot right here or this spot right here. Here's the other one. I have this guy factor. I get those critical points right there. I find the Jacobian. It's a little bit different from before. It is nice because I get the triangular stuff for these three. I'm not going to go through those details. This one I wrote a little bit differently. The way that I get that 1.64 is I divide the 46 by this, right? And just get a number, right? So that goes with this piece, and then I get a 1 here. Why does this top one get the bigger one? Well, because I need that to get up to that. So I would multiply this by 1.64 to get the 46. So that's totally fine too, and sometimes that helps people in class when we're like trying to figure out the slopes of these things and stuff. Anyway, I get this one is a source node. As opposed to on the previous one, was it a same? No, it was a source. This one is a saddle, a positive and a negative eigenvalue. This one's also a saddle, right? And then this one's a sink right here. So what I get when I put them all together is this line that comes in like this line that comes in like this, and this goes to here, and this goes to here. So everything comes into this 1 point right here. So I just want to talk about the two of these together, right? So like I've got these systems that are almost the same. I just flipped a couple things, right? They're both negatives, 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 negatives. Like 3 and 4, they're all really close. 2, 3, 4, those are all really close numbers, especially in comparison to the 60 and the 42. So that small switch of numbers makes a significant change in the nature of the system, where in this one I get 2 points of sort of like equilibrium, and then this one down here I get 1 equilibrium point where everything's just going to fly into that one spot no matter where we start. So hopefully you are feeling pretty good with these. That's all I'm going to have you do today, and we'll do some more tomorrow. So see ya.